Okay, let's look at the graph of ln of absolute value of x. Now, if you remember, absolute value of x is going to take the right-hand side of the graph and reflect it over to the left-hand side. So we're going to start by graphing ln of x. Then I take the right-hand side, reflect it across, and that will be the graph of ln of absolute value of x, right there. Now, for the right half of the graph, the absolute value has no effect. And we know that. If you take the absolute value of a positive number, it doesn't do anything. So the right half of the graph is fine. So we know for x greater than 0, the right half, the derivative of ln of absolute value of x is going to be 1 over x. That's something we've already learned. But now we want to look at the left-hand side. What is the derivative of absolute value of ln of x when x is less than 0? Let's look at some slopes and think about it. So right here, I'm at -2. There's that slope. Let's try another one. Here's that slope. And then we'll do one more. What do you notice all these slopes have in common? They're all negative. They all slant downward. All of these slopes are negative. So you would think that the derivative of ln of absolute value of x would be -1 over x. But it's actually not, because x is already negative. So let's look at an example right here. Let's say this is -3. The slope of that would be -1/3, or 1 over -3, which is still 1 over x. So the derivative of ln of absolute value of x is 1 over x for the left side and the right side. Doesn't matter what side you're talking about, the derivative is still the same. So that's what this says right here. When differentiating the natural log function, ln of absolute value of x and ln of absolute value of u, the absolute value can be ignored. In these cases, the absolute value changes the domain of the function, but does not change the derivative. So you'll notice the domain of this changes, because now we have a left-hand side and a right-hand side, but the derivative for both sides is still 1 over x. So that means I can now do example number 9, where this is a chain rule, mama and baby. So I can take the derivative of the mama times the derivative of the baby, and then put my baby back in. And that's going to be my derivative. Notice the absolute value bars don't particularly matter when taking the derivative of this particular function. Let me label my answer correctly. And there we go. Okay, in the last video, we're going to do 2 more examples of differentiating logarithms, and then we'll be done.